So we are going to start with join.
Mm.
There is a problem. Each time we have to go here and then come to the PPT, we have to escape from the presentation.
ओके, वो दूसरा विंडो में खोलेंगे तो लाइक
Mm, Both both
इनकॉग्निटो
cases.
मोड में शिफ्ट टैब करके मींस ऑल टैब करके.
नहीं नहीं, हम एक बार देख लेते हैं. वो नहीं होगा बिकॉज we since we have to present it ना. After that you have to escape it.
कम बाय
So
एस्केप ओनली.
there is join, equi-join, theta join, natural join, outer join. Hmm. इसके बाद आफ्टर दैट आउटर जॉइन, लेफ्ट आउटर जॉइन, फुल आउटर जॉइन. ओके, यहाँ तक कर लेते हैं पहले. Join is basically, what is join? Join is basically,
फाइनिंग.
we have done Cartesian product now.
हाँ.
So join is basically Cartesian product followed by a select
इनटू.
operation. It's a Cartesian product. Okay, Cartesian product followed by select operation.
ओके.
This is the simplest way to remember what is actually a join. Okay, there are different categories of join, but more or less they're equal. Okay, now another thing you have to remember that theta is a set of all comparison operator: less than, greater than, less
इक्वल
than, equal
टू ग्रेटर देन
greater
इक्वल
than,
टू.
equal to. This is equal to means the equivalent and not equal to. Okay, so we are considering relational algebra syntax from unit 3. Okay, we are starting from the join operation. In our earlier videos we have done already up to Cartesian product. So we are starting today with join operation. So as per the PPT, join is, they have classified join. First of all, the join operation, the symbol of join operation is something like that. Okay, here you have to give the condition. Here you have to give the condition. Okay,
ओके.
so the symbol of join operation is something like that, mod x, or in some other notation you will find join operation is something. In some books, join operation is also,
ओके.
they
इन
they
दिस आई
connected
हैव
these
सीन.
edges,
हाँ हाँ.
nothing else. Okay, so condition will remain there. Now, where do you use join? Now you remember that where we use the Cartesian product to combine multiple tables together to get a result. Huh? Like for example, in you have the schema with you, na? You just open the schema if you have in your machine. You remember the schema, company schema we have provided with data.
Oh, what has happened now? My house computer once again. I had given the glitches I was telling you, na. To
Okay,
give
okay.
that, I had given everything is got formatted now. Everything I have to install it again. I am
Okay,
not.
I am just showing you. Just we take a look at the schema,
JEMP table schema, na.
company schema. Yeah, right. This is the schema. Okay,
uh,
you can take a snap of this too also. Okay, for remembering this structure. Basically, we need a structure. Now, what we will do, we will write a query to find the name of uh, the employees who works in, say, accounts department. Okay,
mm.
say accounts department. We have to find the name of the employees who works in accounts department. Now, tell me, how can you find the name of those employees who works in accounts department? By looking
By
into
matching
this
the
table.
department number.
So here you have to first come, here you have to first come to this table, na, JDEPT.
Mm.
From there you have to find the department number of the respective accounts department.
Mm.
After that, you come to the JEMP
Employee
table
table and find the
and
details of the
find the,
employees.
okay. Now, how do you perform this operation in relational algebra? In relational algebra, you can perform this operation using Cartesian product that we have already done.
Mm.
But still, I want to write that operation once again here. So, mm, tell me, how can you write the thing? JEMP means
In the Cartesian product,
JEMP,
huh?
Cartesian product.
Okay.
Cartesian product, JDEPT, na?
Yes.
JDEPT. So, when you perform the Cartesian product, what you will get? You will get every combination.
Relation. Everything as in relation only will.
Yeah, every combination
Huh.
with all the tuples from JEMP means
Yes. To
one
the
JEMP tuple will be
it
combined
is
with every
multiplication.
JDEPT tuple.
Yes.
Okay, in that way, every JEMP tuple means every employee record will be combined with every department records. Okay,
Correct.
so there will be, suppose JEMP table you
Four
have 10
records and
employees and JDEPT table you have 4 departments, then you will
40.
altogether you will have 40
40.
different combinations. But
Yes.
you know that among those all 40 combinations, few of them will be are of with right combination. Na?
Yes. Yes.
So to fetch out that right combination, we perform a select operation just after the Cartesian product. And
Yes.
what will
And
be the condition select operation? The
select whatever, yeah, whatever the
DNO.
particular field or something.
DNO from
Employee.
JDMP,
Ah,
JEMP will be equal to D number from JDEPT.
yes.
D number. So this will give you the right combinations. This total means this total part will give you the right combination. Means
Yes.
every
Right
employee will
combination.
be there with their own department combination. That
Yes.
combination will be there.
Spurious tuples will be removed.
Spurious tuple will be removed. Right. Exactly. Now from the right combination, we have to find out those all combinations which are combined with the department name research or
Mm.
the, sorry, accounts. Okay, then
Account.
what we have to do, we have to produce another condition here and give an and sign. This is and sign, and
Huh.
d name,
D name equal to
d name
account.
is equal to,
Account.
say, account. I am just writing in short. Okay, you just
Okay, no problem.
understand from this. So what this combination will give you, now this combination, this total thing inside the parenthesis
Mm.
will give you only those records which are combined with accounts
Pura
department and their
and
respective employee
the
record.
employee data.
So among those combinations, we do not require all the
As
attributes.
all
What we
that.
need? We need first name.
We need only the
We need
first.
only the employee name. Na? That means
Huh.
the first name and last name. And this will be your result, right?
Yes.
You just try to remember the thing. Okay.
Yes.
So this was our Cartesian product.
Yes. This was our partition product.
Now we will tell you the join is same. What type? told you here, join is a Cartesian product
Followed
followed
by
by a
select
select operation. See,
operator.
join is a Cartesian product. Here it is a Cartesian product, and this Cartesian product is followed by the select operation. Okay.
Yes,
So
yes.
your join will be like that. If I want to perform the same query using join, then we will write the thing like that. JEMP is very easy. DPT, and here you have to give the condition. DNO is equal to dnumber and dname equal to research. This will give you the total thing. This part is this. Okay.
Okay.
Now from this you have to fetch the fname and lname. Tell me. So you do not have to write this JEMP cross JDPT, then you have to put the select operator, then put this condition. So you remove all those things. You just put this cross and the symbol and put the condition here. That is join.
This once again, this one will be there like that only, right? That relation what we write with the thing.
Sorry, please.
Whatever we write here, it is the same thing. Before the result, we write that first what we required, condition, everything will be there.
Ha,
Instead of
everything.
select the statement, what we write, we directly
Yeah, right.
I include it here using you and
Yes, yes. This symbol by itself making two
join
processes.
both the this thing. Okay,
Cartesian product after select. I write
okay,
here. This is join operator, na? This
yes.
operator by itself is performing two tasks. First, it will perform Cartesian product. Next, it will perform select operation. Depending on this condition, we know that select condition means select operation
Hmm.
is performed on a condition. So this is the condition. Okay. So we do not have to show the select operator separately. So this is simply the join. Okay.
Hmm.
This is simply the join operation, and this will be your result. Okay. Is it clear?
Okay.
Okay.
Uh,
Now, huh,
here, what is this? This is department name is equal to accounts, na?
oh sorry, department name equal to accounts. ACC accounts. Yeah, right. The same condition. The same
Yes.
condition will be there. Okay, we will do one more example so that it can be clear.
Okay.
Mm, take the where it is. ये देखिए पेंट खुला अभी.
आपको अच्छा चला मीन्स कंफर्टेबल लगता है
हाँ, पेंट में शिफ्ट कर जाए.
हाँ करेंगे करेंगे शिफ्ट करेंगे अलाइनमेंट वगैरह में बहुत कंप्लीट
हाँ, नहीं
मीन्स
तो ये ना दिक्कत होते
हाँ
हैं.
डिफिकल्ट है इस सब में थोड़ा
दे.
एक स्लाइड में अच्छे से अरेंज होता है यहाँ पे फिट होता है
अरे ये companies came up where, oh, this one companies. Okay, take another example. Suppose, tell me, mm, find the
हम्म,
department
हम्म,
which are located in, say, Mumbai. Then what you will do?
okay first we have to go to select department location that is J department location
Means you have to make a combination between these two tables, na?
J department and J department location
Right. So you will perform this using only join operation. Then
okay
what you will do? First you will do. Let me save it. Otherwise.
JDPT, Cartesian, the join operator, and JDPT location.
Uh, what we will do first?
That what is
First make
required?
join JDEPT and JDEPT log, right?
Yes.
So JDEPT join JDEPT log
Mm,
JDEPT underscore LOC. Then we have to find what will be the condition. The condition will be we have to equal the D number, right?
mm.
The D number of JDEPT log must be equal to the D
D
number of
number of
JDEPT
JDP.
to get rid of all those Fourier tuples, the
Mm.
extra tuples. Means this
Yes.
production combination, this production department combination will have a combination with this record as well as these three records also.
Yes.
But you understand that the combination of this record with these three records will be of
Spurious.
no spurious. Means this combination is not valid.
Not
The valid
valid.
combination is this one.
Yes.
Okay. So to have that condition, what we will do, the D number of JDEPT location and D number of JDEPT must be equal. So how can we write? Since you see that both the table contains the department D number attribute same name, so we will use this thing JDEPT dot dot D number, na?
D number.
Otherwise, we have to write D number equal to D number. That will make no sense, na? So D number equal to D number means what? From which table you have to locate this D number? And JDPT, sorry, JDPT underscore log dot D number, D number.
Mm.
So this condition will get rid of all
All
spurious
the
tuples.
yes.
After that, what we said, we have to find the name of the department from Mumbai.
Mm.
So now we have to see the location is here, DLOC. So DLOC must be Mumbai, right? So what we will do? And DLOC will be equal to Mumbai, right?
Yes.
So this will give you the right
Uh,
combination.
Combination of the values.
Now what we have to get? We have to
You have
take
to
the
get the
D name,
department name. D name.
department name. So D name. And this will give you the result. Tell me, is it okay? So this is
Yes.
simply join. Okay.
Mm. Mm.
Okay, fine. Now see, they have told you here that there are four types of join. Okay. This theta
Equijoin,
join,
theta join.
uh,
Mm.
theta join is basically, I don't know what is the definition of theta join here, but theta join is basically every join can come under theta join. Means I told you that theta is the, what is theta? Theta is the set
Angle.
of those operators, na? Less than, greater than, less than, equal to, and not equal to, right?
Mm. Mm.
So any join operation with these operators are called theta join. So this
Theta
is
join.
also a theta join.
Okay.
Okay. So any join operation which have a
Mm.
condition with these operators are called theta join. Simply. So every join, in every
Mm.
join you must have a condition, right?
Yes.
Now whenever you have a condition you must have these operators. Among these operators you must have one or two operators, right?
Mm.
So in that way we can say that every join operation is a theta join. So among all these operations,
Mm.
the join that contains this
Mm.
operator only are called
It's called
equijoin.
equijoin. Okay.
Equijoin. Okay. So hence this of our query,
Is
it is a
equation.
theta join as well as it is also a equijoin. Means the join operation that contains only the equal to sign as a comparison operator is
Mm,
called a equijoin, nothing else. Okay,
mm.
I hope they will also did the same thing here. Okay, so this is your equijoin and this is your theta join. We have to know natural join separately and outer join. So first coming to the natural join. Now what is natural join? Now see here in this particular query, a natural join is we have a separate symbol. Some author uses a separate symbol for natural join. Natural join, and that is asterisk. Okay, I also use it. Natural
Okay.
join. Now, what is natural join? Natural join is a equijoin, right?
Mm,
You remember, natural join is a equijoin. Now, uh, before coming to natural join, we have to take a look of this R. How this R will look like. We have to know the structure R. Can you tell me? R will look like, sorry, not this R, not this R, this one, this one, this operation. Okay, how
that
this,
will be the condition or what?
uh, including the condition,
Including the
this
condition.
part, not this part,
Okay.
not this part. Okay, so only this part, this join operation, how the internal table will be there. In the internal table, you will find, see, since we are joining, na,
Ah,
joining means a Cartesian product.
Cartesian
And
product.
from the property of Cartesian product, you remember that the result will contain all the attributes of both the tables.
Yes.
Okay.
So D
So
number,
the
D name.
participating table, all the attributes from the participating table will be there. So D number, D name, DMG are SSN. So let's write. ना इसको copy कर लेते हैं like this. So the uh, right. So your this operation will give you this type of structure, right?
Yes.
Here you can see that D number and this D number both will contain same. Since we take the value of this 4 Mumbai, so this will contain 4. So this will also contain 4 and this will also contain 4. So after performing this join operation, okay, you will have two columns which contain exactly same data.
Yes.
Okay, so this is a misuse of space. Even this table will not going to store by you or by the system, but still internal RAM memory, or you can say this is a misuse of data, na? Means the misuse of space. So we
Yes.
can get rid of the second or the first column. Since
Yes.
both the column will contain exactly same data, there is no sense to have two same columns
Uh,
together. Okay, so to get rid of this column, this column, this column, we can perform natural join. The sole purpose of natural join is to do this, nothing else.
oh.
और कुछ भी नहीं है.
Okay.
See? You just after the class you just read the PPT. I hope the thing will be described same over there.
Mm.
Okay, so the performing natural join, it will
Mm.
remove the second identical column.
Mm.
Okay,
Okay.
that is the purpose of natural join, nothing else. Only this purpose. Now we will perform this operation using natural join, because natural join is equijoin. Okay, and how can we define natural join? Natural join, you can say natural join is equijoin. Even some, although some author, um,
Can we tell it as theta join or equijoin?
I told you that theta join is every join. Every join is theta join. Wherever you use
Ah,
these operators, that will be termed as theta join. Okay,
because here it is not equal. Now that is the reason I thought how we can call
which
it
is
as
not equal.
equijoin.
Hmm? Where it is not equal, it
Here,
is
here. Okay, okay. Sorry, sorry. It is
it is
equal.
equal.
Okay.
It is
Yeah.
equal.
It
Okay.
okay. It is an equijoin. Okay, we can find
Hmm.
it.
Now we represent, we do this same query using natural join. We can
Mm.
perform this natural join
Mm.
because here we are using equal to sign as an operator. Okay,
Mm.
and here we have both the combination have same name table, same name attributes. Okay, now defining natural join, you can say natural join is a equijoin, and the result will do not contain the attribute from
I
the second
same
column.
identical attributes will
Identical
not be
attribute,
repeated.
identical attribute from the second uh, participating
Table.
relation will be removed. Okay,
Mm.
so how to write this operation? This is simple. J D E P T, then write this asterisk J D E P T underscore LOC. Just that.
Mm.
This one. This one will give you this table.
Okay.
Okay, so this
Mm.
one will give you this much only. This much only will give you this table, right?
Mm.
The this operation
Condition
JDEPT
remain.
d number and this d number equality of d number will automatically be performed, since both the table contains the attribute d number and d number. So it will, the join operation will be performed on that columns. This will be 4. Okay, fine. Now
Mm.
after performing this, you have to write the dlog equal to Mumbai. You see, this condition was not there included, but
Mhm.
to get the query right, we have to find out what was the query. We have to find out the department
The
name
department
from the
location
Mumbai.
which is there in Mumbai.
So using this natural join, we get rid of this condition writing from writing. Okay,
Mm.
but this condition we have to specify, na? So how to specify this condition? You have to put a select operation after this combination. Then you have to find the dname, pi dname, right? So this is the natural join. This is natural join. You understand?
Okay.
So natural join is basically an equijoin which will be performed on the relations which contains similar named or similar or attributes or columns with similar name and same domain. The join operation will be performed on that attribute. Okay. Now you can tell me that if the tables do not contain the name same,
Mm.
for example, suppose if you want to
Got it. D number and D
perform
name.
a natural join between these two, here
Mm.
the department number is DNO and here the department number is D number, then the natural join is not possible among between these two tables? No, it is
I
possible.
think it is possible.
It is possible in two ways. The first way is you can rename, you can use a rename operation.
Mm-hmm.
I told you in the earlier videos that there is a rename operation that can be performed here. Okay,
Mm.
JDEPT, either you rename DNO as D number or you rename D number as DNO. After performing the renaming operation, this column will be renamed as DNO. Then you perform the star operation, means the natural join operation. Okay,
Okay.
so you can perform natural join between two tables or two relations with dissimilar names.
By
Okay,
renaming the
by
attribute.
renaming, there is a process. There is, this is one process, and there is another process. The other process is you can always perform something like that. Say JEMP, JDEPT, and under this star you use the term DNO, comma
Mm.
D number.
D number.
See, these are all the conventions. Okay,
Mm-hmm.
some author follows this convention, some other author follows some other convention, but this is a convention that you can perform the join operation, natural join operation, by mentioning the attribute's name here. Now, it is another convention that the first place will mean this and the second attribute will mean
Will
the
be for
attributes from this.
JDP.
So this is another way how you can perform natural join between two tables with
Dissimilar attribute names.
dissimilar attribute names. Okay, but the purpose of natural join, you have to remember, is same. It will get rid of the second
That's,
column.
mm.
Okay, so this was our natural join. So you can say that every join is theta join. I can say every join is
Yes,
theta join
every
because
join
in
is a
every
theta
join
join.
you will have a at least one of these operators. So every join is a theta join. Some of theta join are equijoin.
Equijoin, which are
Yeah,
using the equal operator.
right. Now every equijoin
Is
can
a
be
natural join.
transformed into natural join.
Mm.
Every equijoin can be written also as a natural join operation. Okay,
Can you
that
little
we
bit
can.
scroll down?
Sorry.
Can you please little bit scroll down? That one we wrote it for the this one. This
Okay,
way has to be taken. This select operator and pi, all these things will not need not to be
where?
here. This also we need to consider. Not this
Yes,
select operator
this
to
one.
get the result. Or
Yeah,
it is not required.
because natural join will give you the combination relation
Ah.
only, but
After
it will
that,
remove the second attribute.
mm,
Okay, so the other condition
mm,
you have to mention it how? You have to mention it using a
with
select
the
operation.
select query. Okay.
Okay,
Mm.
see, you can apply a select query on this join operation also, because see here, after performing this operation you can also write a select operation by this thing, na?
Okay.
Means, what I mean to say, that you can write that operation.
I got it. Here the
You got it.
select query we need to extend
You can
it.
break down this query. You can break down this query
Uh,
by taking this condition with
outside
a select operation outside this.
outside that one.
Okay.
Mm.
Okay, fine. So up to this, okay, na?
Yeah.
So equijoin, theta join, natural, now outer join.
Outer join.
Now outer join is something different. Outer join. Outer join. Three outer joins. One is your left outer join,
Mm-hmm.
left outer join, right outer join, and the full outer join. Full outer join. Left outer join, the symbol of left outer join is like that. Right outer join, the symbol of right outer join is like that. Full outer join symbol is like that. Okay.
Mm-hmm.
So here every operation have the condition. So this is the symbol of left, right, and full outer join.
Outer join.
Now, what do you mean by left, right, and full outer join? For to understand that, we take something, say A, B, and C. A1, B1, C1, A2, B2, C2. And there will be another, and we take T. So inside T, we have something that A and D, right? Say I
Mm.
have A1, D1, A3, D3, like that, right?
Mm.
So clearly you can see that A2 means what is the relation between this S and T? The relation is A, na?
A.
So these are the records. This record is for A1, this record is for A2, and this record is for A1, and this record is for A3. Okay, now you can see that this T table missing the records of A2, and the S table is missing the records of A3, right?
Yes.
That is visible here. So
Yes.
outer join will consider the missing records also, means it will visualize. See, first we take left outer join. Left outer join. Now if we perform S left outer join
T.
T and giving the condition S dot A is equal to T dot
In
A.
this also we write this in the left join also the symbol will become it is bracket or that symbol is
Which one? A, this is not
this.
bracket. Okay, means we are, this is
Here the symbol it was something like full join operator. No, that's the reason.
where? In
Here
PDF?
in this example,
In which example?
this one what we are writing now.
Sorry, 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 sorry. Yeah, right. Yeah, this is your left outer join.
Okay.
Okay, so this will be the result. Then what will be the structure of the result, or what will be the result? So this is our R. So R will be, so attributes will be of R will be A, B, C,
D.
A,
A. D.
D. So since it is a left outer join, we have to consider all the records of left.
Left.
So A1,
A1.
B1,
A2.
C1, A2,
A2.
B2,
B2.
and C2.
C2.
C2. Now we have to make choice.
Mm-hmm.
A1, with A1 you will have a combination here, na? A1 and D1. But with A2 you do not have any combination.
Mm.
So you write null and null. This is your left outer join. It's very
Okay.
simple.
Mm.
Left
What is
outer
this
join,
operator is, sorry, what is this operator is written plus after that?
where this one.
Here, above S,
This is T. This is not
T.
operator.
Oh, table
Means
name.
the relation, huh? Table name.
Relation. Okay, okay, got it. Mm.
This is T. S and T.
Mm.
So in left outer join, in the result, you will have all the tuples from left table.
Left table.
In right outer join, this is reverse. You will
Okay.
get all the tuples from right table,
Okay.
and the remaining attributes will be filled with null.
Null.
Huh. So in the right outer join,
Mm. This
what
will
we
be the
will do?
reverse.
This will
Mm.
be the reverse. So S right outer join is S dot A, this will be T, is equal to T dot A. So what will be the structure? The structure will be the same. And what will be the result?
Result will be here, outer table.
In right outer join, you have to write the right side first. I mean, whatever there in the right side, A1, D1, A3, D3. So A1, D1, A3, and D3, right?
Mm. So this side all will be null records.
This
No?
side all will be null. Then the tuples for which no matching is found on the left side, those will be filled with null values. So this is your right outer join. Got it?
Okay.
Now next you have full outer join. Full outer join is the combination of both. So R will be equal to S S dot A is equal to T dot A. So what will be there in full outer join?
It will search both the tables. A common one might be like intersection. If it is available, then only it will be there.
Hmm. A1, B1,
Huh.
C1, A2, B2, C2, but A2, B2, C2 have null here.
Huh. Huh.
Here A3,
A3, D3
D3,
will have this side null.
this side null. So this is your full outer join. Tell me, isn't it simple?
Yes, it is simple.
Okay, these all we can perform with SQL. Okay, left
Mm-hmm.
outer join, full outer join. There you have to write the whole word. Left outer
Mm.
join, something like left join,
Mm.
JOIN. You have to write in that way. So I will show it later. So this is your left outer join, right outer join, and full outer join. Tell me, is this all clear?
Yes, it is all clear.
So this is your binary relationship join. Example of join operation. You must read this PPT as early as possible. Okay.
Okay.
This is same as equijoin, but it allows all other operations like C, theta join. Natural join operation called natural join, denoted by star. I hope the books the faculty is following is also followed by me.
Okay.
Elmasari
We got
Navate
that
for
natural join denotion. Denotion is, means
same.
is denoting same. Star symbol.
And not only that, I whatever the schema
Example.
I gave you
Uh,
way before starting of these classes, means this Jain classes, the exactly same.
Same thing,
See,
SSN.
P name, P number, SSN, DMGR, SSN. That means she also copied
Department
that schema
locks.
from the same book, El Masari
Uh,
Navate, I hope. Okay, outer join, left outer join, right outer join, full outer join. Okay, the symbolically they represent here outer join. See the symbols. Okay,
he is we Srinivas is now he is replied बोल
what?
रहे हैं कि ये अभी 9:23 हो गया आपको लेट हो गया क्या
No, no, no. I am free today.
ओके सो
Wednesday and Thursday, abhi tak, I am free.
okay okay sorry he has replied now he is very bad condition it seems he is having fever vomiting back
Arre
pain
baap re.
acidity fatigue cold headache Papa, completely his health is breakdown I think
Hmm, I will talk with him later.
oh uh,
Why his age is very
less
very less,
might
na?
be
He is I think
he had
23 or
continuously
24.
out he had continuously outside food I think na
That is the main reason, maybe.
mm,
It's very means
we like immunity is very less for him I think so
okay.
he
We will
often is
talk
feeling
with
sick
him later.
mm.
Okay, then relational algebra, join
Join up.
operators. We did outer join operation. See, the
uh,
symbols are little bit different now, but don't worry. The symbols I showed you
yes you showed me both two
here
symbols also you showed me
is the same as the PPT and PDFs. They are not printing
they are
in
not able to
good way of
print.
printing, so that's why they are showing these type of symbols.
Please, can you little bit maximize the PPT screen?
How to this one?
Zoom, zoom. Uh,
Mm.
now I can.
See here the symbols of I
Left,
don't know
right,
from where
full,
they have copied these things from some other
some other
net or
material or book.
see here they are applying a different symbol, but here they are applying the same symbol I applied. Okay, anyway, the symbol is not a matter until and unless you go completely in a different way. So here they are saying that this is full outer join,
This
but
is so somewhere they have taken the screenshot. 8 mark, 9 mark.
I
It is
think so.
seen.
It is not in the book. It's from
It
the
is
net.
not in the book.
So you take this symbol. This is
Okay. It is easy to remember and write also.
division operation. Okay, this is a great operation, division.
Mhm.
But fortunately, we do not require this division operation every time. Okay,
Oh,
so this is a very specific type of operation, division. Division. Now, what is division? For understanding division, we have to division. The symbol is this one, the arithmetic division sign. Let's see what they are using as division.
same.
Okay, the same. Okay, so the division operation is basically, let me give you,
Repeated subtraction.
yeah, but A, B, and in T, you have some, say B. Okay,
Mm.
suppose you have here A1, B1, A2, B2, A1, B2, A3, B4, A3, B1, A3, B3, A B4. This is B4. Okay, and maybe you have A4, say B1, right?
Mm.
Here you have B1, B2, B3. Okay,
Mm. A4 B1 is repeated, no problem, na?
no problem. This is a arbitrary data. Okay,
Okay.
now what is division? Division is basically, suppose we are going to perform the division like that, S divided by T. Okay, so this is the division we will perform. We will divide the S relation by T. Okay, now what will be R? R will be what will be the structure of R? The structure of R will be means the attribute.
Mm.
Just a minute. Just give me a minute. Just a
Okay.
minute. Somebody is calling me.
Okay.
Hello.
Yes.
हाँ. अच्छा. Suppose
Mm.
this R relation,
Mm.
this S relation has the attribute set, say Z. The attribute set of S may be set Z, and the attribute set of T, say X. So the rule is division can only be performed between S and T if X is a subset of Z. Are you getting the thing? Means
Uh,
see here, what is Z? Z is equal to here, tell me, a set of all attributes of S, means A
okay.
and B. No?
Uh,
What is X? X is the set of all attributes of T,
T.
B. Now you can see that this is a clear subset of this set,
Yes.
hence the division is
We can
possible.
perform the division.
We can perform the division. Now what will we say? R, the set of attribute of R, uh, say this is Y. Okay, so the formula of Y will be your Z minus X.
Okay.
Z minus X. So what will be your Y? Y will be your A.
A.
Means AB minus B is equal
A
to.
will be left out.
So your R will be what? Your R will be A only. A. Okay. That means what? We have to find some values of A na,
Mm.
from this table. We are dividing S by T. Means we are trying to find some values of, this is A. We are trying to find some values of, this is 1. I have to write it clearly. Otherwise there will be a confusion. A1. So we have to find some values of A
Okay.
depending on some values of B. Now what that time? Depending on the values of some B means, division means find all the values of this column, means this one, okay,
Mm.
from this table, from the S means uh,
A and B.
what it is called, dividend, it is
Mm.
divisor, okay. So find the attribute, find the values of all A's which comes with all combinations of B.
Mm.
Means you have to find those A which comes with all these three B's, B1, B2 and B3. Now see, A1 comes with B1. Does
A.
A1 come with B2? Okay, A1
Yes.
comes with B2, B2, B1. Does A1 comes with B3?
Yes.
A1 comes with,
A1 is not there with B3.
there should be, maybe I make it. Here, A1 is also comes with B3, na?
Okay.
So A1 is a value which comes with every B1, B2 and B3. Maybe not every B1, B2. A1
Mm.
is comes with all these B's, means B1, B2 and B3. So A1 will be there. Okay.
Okay.
Now search for the same. Whether
A.
A2 comes with B1, A2 comes, A2,
Yes, it is there here. No, no, no. A2 doesn't come with B1.
A2 doesn't come with B1. So A2 will not be there. Does A3 comes with B1, B2, B3?
Yes. B3 it is there, but
No.
B2 it is
A3
not
do not combined with all B1, B2 and B3. So
there. Mm.
A3 will also not be there.
Mm-hmm.
A4 will also not be there because A4 has only one tuple, that is with B1. So A4 will not
Okay.
be there. So only A1 will be there.
Only A1 is going to be there.
Okay. So what is the meaning of this division? Division means it will find the records of this attribute, okay, which comes with every combination of with these tuples, these values.
Mm.
Means you have to find the values of all A's which comes with every B values. Now
Mm.
take a simple example from here. See, we have in this table, we have the records of employees, na?
Employee.
And in this table, you have the records of all employees who works in which project, right?
Mm. Yes.
Who works in which project. Now we can perform a query like that. Suppose Virat Kohli Virat Kohli
Mm.
is working in some projects. Okay,
Mm.
Virat Kohli is working in some projects.
Yes.
Suppose I want to find
Mm.
those all employees
Mm.
who works in all projects with Virat Kohli. Are you getting the thing?
All projects with Virat Kohli. Yeah?
Right.
Okay.
I want to find those employees who works in all projects. In all projects. Maybe Virat Kohli works in 4 projects. Okay.
Mm.
So some are there who works with him in all those 4 projects. Some of their works with him in 3 projects, in 2 projects. But I want to know those all employees who works with him with all those 4 projects. Are you getting the thing?
He only can associate with only one project. No,
No, no, no. Why?
we have to assume that
Employee,
he can work in
employee.
more than one project.
Yeah, obviously, an employee can work in multiple projects. Na?
Okay.
Maybe not in the same time, but in a different time after the completion of the project. Does the employee leave the company? No, he will be assigned with another project. Na?
Oh, correct.
Just like that, Virat Kohli is playing World Cup
Mm.
2019. So after playing World Cup, will he be removed from the team?
No, no,
Not
no.
like that. He will play again another World Cup, something like that. If I
Mm.
take World Cup as a project, okay.
Mm.
So I want to know all those players, maybe in playing field, who works means who played with Virat Kohli in all the World Cups till now.
Mm.
Okay.
To which role the project Kohli was assigned.
Hmm, hmm, hmm. So this is a kind of division operation. Okay.
Okay.
So you have to remember for all. This is a phrase. For all, with all, something will be there. Means this for all types of phrase. This type of phrase will be there in that kind of query. Okay.
Mm.
So this is a hint, simple hint that this phrase means for all. If you find in a query for all phrase, then you have to identify it. Maybe that query needs a division. You have to identify it in that way. This is a hint. There is no hard and fast rule in that. Maybe the sentence is giving in some other way. But generally, the queries, the sentence given that includes for all needs a
Mm.
division. And division is rare. It's a very specific type of query. Do not require every time. Okay.
Mm.
So this was the division. I am not going to perform that division of Virat Kohli. You may try. I am just writing that query. You may try it at
Oh,
your home
okay.
and can send me for checking. So find the name of all employees who works in all, see, all projects with Virat Kohli. Okay. So this is a sample query. You can perform it. Just try. Okay.
Mm.
Is it okay?
Yes, it is okay.
Okay. So this is your division operation. After that, uh, Smith. Actually, I
Same book,
find
huh?
the name of all employees who works in all projects with John Smith. That is the
What?
query given in that book. Okay. So the faculty is taking the example from Smith. That's why he is giving the name Smith's phone number. Maybe he or
She
she she is, for
referring the same
example,
book.
but where the query statement, she should have given the query statement here. Na? Otherwise, how can this be performed? From where this comes on?
Mm.
So the statement of this query is something like that.
Yeah, what
Find
it
the
is
name of
written.
all employees. I am writing for others may who have that book may find it easily. Find the names of all employees who works in all projects with John Smith. Okay. So this was the actual query
Okay.
for which this has been performed.
Mm.
I also performed this one, but in my words.
Somewhere it is
So,
written here division, only the division operation has been given.
but I told you the query statement. I am not finding the query statement here. Maybe in the live
It
classes,
is not
he was
written in the live class. You would have told that.
maybe had told the thing. Okay, division, everything, additional operation. Okay, aggregate function. Fine. Let's move quickly to aggregate function.
Mm.
Without aggregate function, most of the queries will not be performed. Maybe from exam point of view, aggregate functions are very much important. So there are five aggregate functions.
Oh, in that five are there. Okay.
आजकल मैं बहुत स्पेलिंग मिस्टेक कर रहा हूँ मतलब I don't know what will be the reason.
Even I do that. For me also, it is becoming very much.
हाँ बहुत सारा मतलब कि I feel
And
while
that
writing.
reverse way I generally am doing.
Hmm.
So, for example, to type the, I make first TEH. Find also, I do the same thing. FNID, I will type. Just two letters, I will interchange in many things.
While typing, I can type very fast. I can type very fast by not looking at the keyboard, but
Keyboard.
just like
Mm-hmm.
manual typewriter. I had two manual typewriters in my home in my earlier days. Uh,
Mm-hmm.
I was a very good typist at that time. Personal
Okay.
typewriters were there, not
Um,
electronic. That manual old typewriter.
yes,
Okay,
yes, I remember. I do remember. I
one
have
from
used that
Godrej,
for
another from
Canada.
Remington.
And
Remington.
I have went to the class
Hmm.
for English and Kannada.
Hmm.
And English I couldn't complete it. Means I did not take that as an initial one.
Hmm.
I moved to a different location at that time.
Hmm.
Kannada to I think two tests I have taken in Kannada.
Okay, okay, fine. That sentence, the quick brown fox jumps over the lazy dog. You remember the sentence that contains all
Yes,
alphabets
yes,
from English.
yes. Alphabets
That was the final practice session was there in type. The quick brown fox jumps over
to
the
give
lazy
the
dog.
font to this thing
Mhm.
to
So
define all the font.
I can type by seeing the books and the documents. Okay, but while typing from mind, so currently I am feeling
Mhm.
for a few days before.
No,
Maybe there is
maybe
some
you are
chemical
a
locha.
little bit
It's
disturbed. That's the reason.
called. Uh, I get confused in some spelling. Anyway, aggregate functions. So there are five aggregate functions spatially. Okay, what are those aggregate functions? Those aggregate functions are first is your count. Let me type it first. COUNT count. Another is your say max. If you want to
Okay.
find maximum salary. Now count, where we
Mean.
use count. If you want to count the number of employees we have, if you want to
I,
count the number of projects from Kolkata we have, if you want to count
mm,
the number of employees who earn more than 10,000.
mm,
Okay, so in that way you have to use count. Max, if you want to find the maximum salary you paid to the employees from Chennai, there
mm.
you will use max, mean,
Mean.
AVG or average. Okay,
Average.
so what is the average salary you give to the employees of production department, something like that. Okay, and the last one is sum. So what is the total amount of salary we give to our employees?
All Excel functions, or how they
Yeah,
perform similarly.
not all. These five functions are there.
That's what
Together
I
they
mean
are
to
called
say. These five
aggregate function.
aggregate functions only. Uh-huh.
Okay, aggregate function. Now aggregate function in relational algebra, aggregate function symbol is is quite funny. Means not, I don't know, in a cursive F, how it is written,
Oh,
something like that.
okay.
Na? So this is the
Uh,
symbol of producing aggregate function in relational algebra. Here you have to write the function name.
condition.
But for simplicity, I use the term F.
Hmm.
Okay. Just let's see what they are using here as a, see, cursive. They are also
cursive है.
using the short version of cursive F. Okay, but no problem. You can use only single F, this simple F. Okay,
Hmm.
so F, so you have to use function here. Okay, now take one example. Count how many employees are there. Total employees. Total employees. So how can you do that? Very simple. R will be your F account. Now inside count, you have to pass something.
Attribute name and
Say
table name.
SSN. So if we count SSN from JEMP, okay,
Hmm.
then you will get the total number of employees.
Employees.
So what will be the structure of R? The structure of R will be something like that. Count bracket SSN. Now this looks ugly, na?
हाँ.
Say 10. We have 10 employees maybe. This looks ugly. Count SSN. So you can use the rename. How? R say dot emp, then give this thing. So that
Renaming will be done to the attribute.
renaming will be done. This will be your dot emp.
Structure will be total employee, and then all the count means
Okay.
the count will be given.
Okay. So this is simply your aggregate function, how you can use the aggregate function. Okay. So now if you want to find the total amount of salary, so what you will do? Oh, F, you write F and sum salary, something like that.
Okay.
Okay. Okay. Okay. So count, max, mean, sum, average, all are
Hmm.
same. See,
Yeah.
max salary, they did not mention
Means
the parenthesis. You should give the parenthesis. Pass the salary inside the parenthesis. Okay.
hmm.
Then grouping. There is something called group by. Aggregate function, after that you have something called group by. Group by. Now what is group by? See, here you can ask for a query that count the total number of employees city wise. Means how many
Oh,
employees
here
are there
city
from
wise we are
Bangalore?
grouping.
So that type of
Okay.
query is specialized over this aggregate function.
Aggregate functions.
It will be used with aggregate functions only, group by. Okay,
Group
aggregate
by.
functions,
Okay.
aggregate functions enhanced with
It's
group
group.
by. So how can you
Okay.
use, let me write the query statement. Say count dot employees city wise, means how many employees from Bangalore, how many employees from Delhi, something like that. Okay, so what you will do?
Hmm.
F count SSN
JEMP.
JEMP.
Group by
Group by आपको you have to put group by here. So group by on what? Group by on city, because
city.
we have the column name city here. See,
Hmm.
okay. So this will give you a result like this. Say I am applying renaming to be
यहाँ पे
better.
सिटी नेम मेंशन करने की जरूरत नहीं है क्या?
No, what is the query? Just read it carefully. Count dot
Okay.
employees
It
city wise.
Just like city wise, it will be rearranged
Not
or
arranged.
sorted.
Arrangement is different. It will count the total number of employees
Oh,
city
got it,
wise,
got it,
means
got it.
group by.
Okay,
It
okay,
will group all the records on cities group. After that, it will produce a count.
okay,
It will first group. It will first group on city. After that, it will count. So the result will be like that. Say city, then .emp. So Bengaluru. From Bengaluru, you have two. From Delhi, you have
okay,
three. Say from Mumbai, you have five. Something like that. Okay, you got it.
yeah.
So this is your group by. Okay. Now suppose if they give you a query like that, find the total number of employees from Delhi. Then what you will do? यही एक query दिए. Say find how many employees we have. Find how many employees we have from Delhi. कैसे करेंगे?
Okay.
First you have to perform this operation, right?
Mm,
Which already we did here.
mm,
First you have to perform this operation. So this operation will give you, see, this operation will give you this table, na? This table.
mm.
Got it?
Yes.
So over it, you put a select statement where CT is equal to Delhi, right?
Mm,
So what you will get? You will get only this thing.
okay.
From this, what you will fetch? You will fetch the
On
.emp,
totally empty.
column. So
Mm,
you will get your result, and it will be 3. It will be 3. This 3. Tell me, is it okay?
yeah.
So first you have to group by the employees on CT.
This
After
was
that,
there in one MCQ, na? How this order will work?
was
Group
it
by
there?
from where tables is this group by
Maybe.
uh,
Okay. So this is your aggregate function, how they are written separately and how they are written with a query, inside a query. Okay.
mm,
Tell me, is it clear? Aggregate function.
yes, sir.
There are, see, this is cursive
They have
F.
copy pasted. Symbol is like this
uh,
करके.
uh,
After that, they have taken the
uh, example of aggregate function. I will send you queries,
okay,
many queries on this thing. Okay.
okay,
So just try to perform all those queries. If you can perform, then you will understand the query, every type of query. Okay.
okay,
I have a full set of assignment, and
okay.
understanding relational algebra well is very good for writing a SQL query in Oracle or in
Yes,
any
yes,
database.
yes, yes. It was.
So aggregate functions and grouping.
I want that schema if you can send me, please.
Yeah, sure. It has
I'll
already been uploaded on that. Yeah, as far I remember, those. है ना, I library we have.
the schema is also there.
Yeah, I did total folder. I uploaded total folder. Means
Okay.
that time I was uploaded. Say what was it?
Yes,
Lib
yes.
dot lib.duttangier dot in. Still, I will send
Oh,
you.
I was
See,
thinking this YouTube one, this thing.
exercise, books, notes, video
Okay.
links, discussion meeting. See here, DCNA.
Second sem
What
is continued in this, huh?
second semester? Huh.
Okay.
Oh, RDBMS 7. Oh, सेशन 3 तक था means ERD.
Mhm.
Okay, I will upload this here also and I will send you
Okay.
those things
I'll
too.
check
Okay.
with this link then. Okay.
Okay, so it was example queries with relational algebra. Okay, they have given some examples, only two examples although.
Hmm.
Okay, so this ends your this PPT.
The
Okay,
third unit PPT, right?
third unit PPT. Now, what was there in the next unit?
I think that is pre-recorded class is also there on this one. Something.
Relational algebra. Relational algebra overview.
It
No,
is
no.
fifth unit is this.
Then what is
We did now
third
unit
unit we completed, na? Nah, fourth, fifth unit we completed.
fifth unit we have completed.
Acha,
Okay.
mapping this one,
Huh.
this one. Okay, what is there inside this mapping conceptual? Oh, it is 10 p.m.
ERR
We
model
should,
testing, enhanced entity relationship
ha,
model.
ha. This is very simple. Okay,
Okay.
this is
I
specialization.
think
You
with
will,
the inheritance concepts is
ha,
we need to go.
specialization. This is inheritance basically. You should have a sign over here, just like a
For
E.
this easy in OOM
Is
also
a,
you was telling.
I think we already discussed this thing. Is a relation, aggregation. We have completed ER diagram, na?
ER diagram we have completed. Something
So
mapping I think we need to
mapping
just
means mapping
okay.
cardinality. One is one to one, one to n, many to
Okay,
one.
okay.
That is mapping
Uh-huh.
cardinality. See,
Okay.
one is to one relationship.
Yes, one to one.
We
Correct.
did this. We
We have done
completed
this.
this.
We have
Okay,
completed.
okay, no problem.
Just once if I read out this PPT, it
Yeah,
is
sure. You should
will
revise.
be done with 5 and
So,
6 today.
so up to sixth unit we have completed.
Six units we have completed today.
Seventh unit, I hope this will also be we had completed because this is our SQL queries in SQL.
Queries though we have done already. Many
Means
commands.
not completely. Okay. So in next two classes, we hope we can catch up with PLSQL.
RDBMS, right?
Yeah, RDBMS. I have PLSQL notes for my own. If you
Okay.
want, I can send those
Yes.
notes to you also. Anyway, so in our next RDBMS class, we will complete all those things together.
Tomorrow is Friday, na?
Tomorrow is Friday, but unfortunately tomorrow I will be
I know.
engaged.
For me also, I have also got something. Uh, yeah.
Sunday we can take it.
Sunday we can do.
Yeah, Sunday we can take
Okay. I think Saturday you are not free, na?
it. Saturday, Friday,
Okay.
Saturday. Mm,
Huh.
no,
Okay.
no.
We can do it on Sunday then.
Sunday.
Sunday
Okay.
will be
Sunday we will catch the
6:30, I think, na?
catch them. We
Huh.
will complete this RDBMS first. After that, we will go to those Java or kya, that
The
algorithm.
object,
Okay.
the algorithm analysis
Hmm.
that we
So
will.
Sunday, I hope they will start normalization. so we can cover up to normalization Sunday.
Okay. Sunday what time?
Sunday evening after 7, I am free. No
Okay,
problem.
we will sit at 7.
Okay. So you just send me message.
Hmm.
I will join. Okay.
Okay.
Okay. Then today up to this. Thank you.
Thank you. Thank you so much.
Okay. Thank you. Good
After a
night.
long time, we